Hello, everybody, and welcome back to the 7th episode of Active Inference Insights. I'm your host, Darius Parvizi-Wayne, and today I have, for the first time, two guests to bring you. Vicente Raja is a research fellow at the University of Murcia and affiliate faculty of the Rotman Institute of Philosophy at Western University in Canada. His research lies at the intersection of philosophy, cognitive science, neuroscience, and the history of the sciences of the mind. In 2021, he was the first author of the paper The Markov Blanket Trick on the scope of the free energy principle in active inference, which argues that, quote, the FEP is not the general principle it is claimed to be, and that active inference is not the all-encompassing process theory it is purported to be either. We also have Jeff Beck. Jeff is a computational neuroscientist studying probabilistic reasoning in humans and animals. He is also the senior machine learning research lead at Verses and is a critical contributor to the active inference field, writing, among others, the paper Markov Blankets and Bayesian Territories. Guys, thank you so much for joining me. It's an absolute pleasure. We were talking off camera. There may well be some points of divergence, but we are 4 days away from Christmas at the time of recording, and I think the baby Jesus would want us to find some conciliation. So we will do the most we can to strike at differences and elucidate differences and see, but all in the spirit of hopefully collaborative science and collaborative thinking. So, with that in mind, I think where we could start is actually where we have no issues with one another. So, looking at that paper, where are the kind of points of just neutral, placid? This is like a good starting point. Vicente, I don't know whether you want to start, given that you wrote the paper, but where do you see where Jeff's work or the other key contributors to active inference, where do you see that, some of the stuff they say is actually pretty uncontroversial?
Good question. So first of all, thank you for having me here. I think I could start with a very brief detour on why I wrote this paper, or why we wrote this paper, or even why the paper is the way it is. First of all, I started writing it to make sense of the FEP and active inference for myself, right? To try to see how it was derived, the steps, and actually section 2 of the paper remains there just as that, right? As starting with a random dynamical system and just trying to go step by step there. So this is, I think, one of the points in which we converge is, at least from my point of view as a person who works in the philosophy of the cognitive science and the cognitive science themselves, that dynamical systems is a good way to look at cognitive systems. So that's, I think, we are in kind of the same camp. Then maybe the modeling strategy that people like me that comes from radical embodied cognitive science and ecological psychology to model dynamical systems, and the Bayesian twist of it that you find in active inference are slightly different, right? But this first step, this first point, I think is a point of convergence too. But then after we made sense, we think of the free energy principle and active inference, our point was, okay, let's accept all this formalism is good, right? We don't challenge it. We just accept, like, this is right. But even accepting that, we have some questions about it that those questions have to do more on how different bits of the formalism relate to different aspects of cognitive systems and their relationship with the environment, right? So, and I think this is where the divergence is stronger. So I think the convergence has to do with the primacy. I don't know if the primacy if is the word, but the attributing importance to a dynamical systems take on all these issues, and the good spirit of trying to find formal methods to study it. And our divergence, I think, has more to do with some conceptions on how to best address dynamical systems or cognitive systems in dynamical terms and all that stuff. Yeah.
Excellent. Okay, that's great. That's a great start. Jeff, let's go to you. Let's imagine that you're reading the Markov Blanket Trick for the first time, where we will come to the divergences. I promise you.
I can tell a story, or I can. Well, so I'll start in the spirit of this. I'll start off with the point of agreement that
Please.
I had with the paper, which was one of the there are two sort of often discussed problems with like the FEP literature. One is that it uses idiosyncratic notation and it can be very difficult to understand. The other one is the thing that apparently causes a lot of ire, particularly from philosophers, and I agree that this is a bit of a problem, which is there's a penchant for rhetorical excess, if I could say such a thing. Which is to say, I don't think that there's many problems with the FEP as a whole, but I think that it could be presented in a more compact and concise way that avoids, some of the more philosophical claims that are often sprinkled throughout these manuscripts. And I do think that would create both, and that this is something that would create both a bit more clarity, and is something that people should poke back to. Like when you say if you find yourself, and this is my personal view, this is not like everyone who does this, but if you find yourself putting the word thing in scare quotes, you might want to think maybe you're doing something wrong, right? It's just sort of like my knee-jerk response. And so, that I think is certainly a point where there's definitely going to be some agreement, which is that, for me, mathematician, simplify things, be explicit. That's the beauty of it. Don't add things to the equations that aren't necessarily there. But of course, every scientist does this, right? We all want to sell our ideas. We want to make them as big as possible. And so there is some of that. And I think that in particular, because the math is so difficult to understand and follow, right, has that those sorts of excesses have become the focus, right? That's easier to sort of like say, oh, that's, this is a problem. This is a problem. And so, yeah, that would be the point of agreement. If I were to quickly and compactly summarize the point of disagreement, I will do so by telling the following story. So when I first came across Carl Friston, I was at the Gatsby at the time. And so Carl Friston was like literally in the building next door. And that's when I first came across him, and I saw him present his stuff, and I read a couple of his papers. And for me, there were many things that I was like concerned about. Let's just leave it at that. Let's say concerned. We can get into it more later. But the one thing that wasn't controversial at all, in my opinion, was the Markov blanket part of the story. And that and my hope is that as this conversation proceeds, I'll be able to explain what I mean by that, and maybe come to some sort of consensus. So I'm happy to do that now, but I feel like
we will unpick stuff gradually. That's quite a good irony. The Markov blanket was kind of the point of this bit works. Yeah, I mean, I take your point that the maths ought to be elegant, parsimonious, as much as possible. But unfortunately, or fortunately, any grand unifying theory comes with it: the philosophy, the cognitive science, the neuroscience, the theoretical biology, and so on. And so I think it's an inevitable consequence that we get wrapped into epistemological and ontological questions. But we will do our hardest to unpick them with simplicity, because I think that's actually all that we're aiming for. So I read the paper. Obviously, I read it multiple times, and I read the commentaries and your response to the commentaries. And for me, there were about 2 or 3 distinct critiques of the free energy principle and active inference that I think we could have a good conversation about. The first is that Markov blankets fail to capture all possible types of conditional independencies. So, for example, candles, the candle relationship to the external environment, or groups of people, cultures, societies, their relationship to whatever those external dynamics are that they're shielded from via the Markov blanket. And then linked to that, and then I'll leave it there, is that these things, to use Jeff's quote marks, have properties, certain things have properties that cannot be captured by the Markov blanket formalism. And Vicente, you mentioned relational properties, and constitutive self-organization. So I don't know whether you want to take those as two separate things, one being the incapacity of the Markov blanket to capture all types of conditional independencies, and then those two strands, the constitutive self-organization and the relational properties. I don't know whether you want to take them separately or whether you think they fall under the same blanket, if you pardon the pun. Okay, we'll do it separately. Jeff has just pointed to me. Let's start, therefore, with the incapacity, as I said, for the Markov blanket to capture all conditional independencies. And let's use, for sake of simplicity, this object that I selected before, the candle. What does the candle tell us about the free energy principle? Vicente, please.
Actually, we use candle flames because it is an example that was in the literature, right? It seems, if I remember well, I haven't reread the paper, so I might be not fully accurate about what we claim there. But if I remember well, the issue with the Markov blanket is that what we can take as blanket states are changing too fast in time. So there's no way to find them and to know and to measure them over time in the way that is required by the formalism. And if I remember well, Thomas Parr talks about it in his commentary to the Markov Blanket Trick. It's actually the only commentary that concedes that we might be right in something, which is an interesting thing, but it's okay. And he claims that it could be solved if in this kind of systems, or in this kind of things, quotes, we look to, instead of looking to states themselves, we can look to densities of states. We can try to model those states. And I think this is an interesting move that points out why we think that there is more about the Markov blanket than just to say, oh no, it's just the simple answer to how to differentiate these, the internal and the external states, right? The free energy principle and active inference doesn't really tell you whether you have to choose states or densities of states as the blanket, right? So you are putting extra assumptions there on how you choose to do that. And this is kind of the overall thread of the critique. When we claim the free energy principle is not the principle it claims to be, we are not claiming that it cannot be used as the principle of least action to write down some equations, but that it seems like just from this principle and from answering two simple questions, what is to be a thing and how to differentiate it from the environment, you have everything. And we try to posit examples in which you always need an extra step, you always need extra assumptions that are not always clear when you only appeal to the formalism. So this is the role of why we think that the fact that candle flames, as an example that was in the literature, why candle flames are important. I think they point out that you always need extra assumptions that are not always clear in when you only appeal to the formalism.
Great. Perfect. That's a really nice exposition of the claim that you're making. Jeff, I'll jump to you then. It would be, retort to that would be wonderful. And I think actually with specific mention, if possible, of this dichotomy that Vicente mentioned, which is, are we talking about states, some kind of ontological thing, again, or are we talking about probability densities? And where does that line become blurry? What actually is that difference? Or is it just, are we just making a kind of false identity claim? What's what's really going on here?
So I think that the best way to respond would be so the short, pithy, and dismissive answer is to say I solved the flame problem. I wish I could share my screen. I have some really cool I realize some really cool graphics. So one of the other problems that when conveying the free energy principle that its proponents have faced is the fact, I sort of said this, the math is really hard. And in order to make it tractable, a lot of additional assumptions get put in along the way just to make the math easier, right? And some of those assumptions are necessary to make, many of those assumptions are not actually part of the free energy principle by itself, right? Or part of the Markov blanket story on its own, right? But are done to make the math easier. Like when I first came across the FEP, I thought there was no difference between active inference and KL control theory, right? And the reason why was because when they go to actually solve the equations, they make some additional assumptions to make the math easier so that it ends up being equivalent to KL control theory. But if you go in and sort of say, well, what actually is the principle itself, as derived either as Carl does it from statistical physics, or the way I prefer to do it, which is directly from information theory, right? That's not the case, right? The actual objective function of active inference involves solving these complicated path integrals and things like that. But to make the problem easier, to make the math easier, to make it more solvable, additional factorial assumptions are built in. And a lot of people jump on the fact that it's you have all these additional assumptions that kind of but those are done often for computational reasons. They're not necessarily part of the theory. We like to joke that, everybody talks about the generality of the path integral formulation and Jaynes maxent and how it's mappable onto statistical physics. What people often forget is the problem with the path integral formulation is you actually have to solve path integrals, which is a serious pain in the butt. And so this is sort of my summary. One of the things that has contributed to a lot of confusion has been these additional mathematical simplifications that are then taken to be part of the theory when they are not. In regards to the flame story, because I know I gave a pithy and dismissive answer, and that was just, I will fix that now in the interest of politeness. The reason that I didn't think that the Markov blanket story was at all controversial was because of its link to systems identification theory, right? The Markov blanket itself basically just specifies the domain in which systems identification theory can apply, right? So the idea is that, so how does it, so when you, I don't have, so system, environment, inputs, outputs, right? If you're doing systems identification theory, you're basically saying, well, what is the system doing? What is its input output? This is very colloquial, right? We can make this more specific. What is its input output relationship? In order to do systems identification theory, right, you need to know what that input output relation, that's the goal, is to figure out what that input output relationship. And if you see a particular input output relationship, that gives you the label for that kind of system, right? It's a system of type X because it has this input output relationship. The Markov blanket is basically just specifies the domain in which you are going to do a statistical version of systems identification theory, right? It's the domain of the inputs and outputs of it. So when somebody says, I have a big system and there's lots of stuff in it, and I'm going to segregate out a little system from it. The mere fact that you can do that, when you say this is a subsystem, you have already said that there's a Markov blanket. Does that make sense? Right? All subsystems have blankets, by definition. It's sort of implicit. That's why I never thought that it was controversial, because what do? We want to say, well, that's a subsystem. That's an important thing. It gets its own label, and so it has a blanket. It's it's the way we do systems identification theory. So sure. I don't know. I want to see if Vicente has a response before I move on to the flame. In Please. Particular,
I mean that's kind of that's what I read when I was reading the literature more. It's kind of it's non-controversial for the people who work on it in that sense. You identify a system. There's a blanket and there's an external state. I think, and part of the Markov blanket trick is to see different issues we find with that. That for many systems we are interested in, we don't see it to be so straightforward. Like when we model with dynamical systems, for instance, with the HKB model, the behavior of two-coupled oscillator, where the collective variable is relative phase. Our system is the couple oscillators. So you can put a blanket around it, I guess. But then what's the environment? It's the blanket put on the phase space of the relative phase, which is not a property of any of the two things there, right? So, I mean, I kind of understand the abstract sense, but then I don't exactly see how these apply to kind of systems that we are interested in.
Right. So I'll just quickly respond. So the problem with the whole Markov blanket part of the story is that there's just too goddamn many Markov blankets, right? So you have this big complicated system, right? And even if you're going to limit yourself, as they often do in the FEP literature, to like static Markov blankets, right, where once a particle or a constituent component or whatever has been assigned to either environment, blanket, or object, it's always there. Right, so this is a situation where there's no such thing as matter transfer, right? Which is why the flame case, by the way, like doesn't work, right? The flames have Markov blankets, but they're not static, right? Because as the matter, as it burns and moves in, and fuel comes in and exhaust goes out, right? The matter is constantly. So if your definition of a blanket is that it's tied to matter, then yeah, you're right. Like you can't do a flame at all. But but putting that issue aside. The problem with Markov blankets is that they're everywhere. You have a glass of water. Every single fluid element in the glass of water. So what's a fluid element, right? You take a glass of water, you draw a little circle. I mean, obviously it's 3D, right? But an arbitrary fluid volume has a blanket, right? And we know this. Like when we do finite element methods for simulating them, we take our glass of water and we make it into lots of little cubes, and all the cubes are connected, and the boundaries between the cubes form the blanket. There's too many blankets. Blankets are absolutely everywhere, right? And their boundaries are often completely, like where you're going to put your blanket is the hardest problem to solve, right? And I think that the free energy literature has not worried too much about the problem of where you're drawing the blanket, because the idea was if you've got a blanket, then it's subsystems have blankets, right? We're interested in subsystems, and so now we can just like put that problem aside. But it's a really difficult problem to say, well, what is the principle that tells me that this gets a blanket, right? Why is a blanket that's around, a bubble rising through my glass of water the right blanket, as opposed to an arbitrary blanket around a fluid element that has no bubbles in it, right? And I don't think that question has not been adequately addressed in the, in my opinion. But I believe that there is a notion that is sort of implicit in the FEP approach that handles that. And so when I sat down and tried to solve the flame problem, I asked myself, well, what additional principle? And this might make Vicente happy, right? There is an additional principle. He was absolutely right. I think the principle was implicit, but the additional principle is like, how do you choose your blankets? Well, you choose them for parsimony and simplicity, right? In other words, we use the scientific method, right? You take all the ways that you have this complicated interacting system. You take all the ways that you could draw the boundaries in them, and there's like not uncountable, but there's a really large number of different ways that you could draw your blankets. And the way you pick the one that's important is the one that results in the greatest simplification of the resulting dynamics. This is basically like you can think of this as mean field or coarse-graining if you're a physicist, right? That's what coarse-graining is that you segregate your system into macroscopic variables or macroscopic components if it's a mechanical system. And the choice that you make as to how you're going to do that is to basically make the system as simple as possible. If you take that approach, then if you take that approach and apply it to the flame situation in particular, that's exactly what you discover, right? You discover that the blanket of a flame, right, is just outside the reaction zone where all of the exothermic reactions are going on.
Okay, excellent. No, I think we're agreeing too much. And that's going very well.
I love the flame problem. I like that.
Yeah, that's gorgeous.
I really wish I could share my screen because I like queued up some videos and and had some figures that I was like, just in case.
Well, if
but the flame case really is cool. I'm going to publish that soon. I'm just working on. I'm trying to get like a whole. I'm working on a. I took some data from. Do you guys know what particle lineage? Well, everyone knows what Conway's game of life is. So this is Conway's game of life, but for interacting particles. And so they get these particles to do cool things. And so you can put in a random bunch of particles and they form a cell membrane, and the cell membrane grows stuff like flagella. And so we applied it to that situation as well. And what you find is that the blankets are changing over time. And as they change, the identity of the object also changes, which is exactly what you want, right? And the reason for this is because the blanket itself, the blanket alone is meaningless. Right? It just specifies the domain in which you're going to do your system identification or dimensionality reduction. Right? What really defines an object's type is the statistics of the domain. Right? And so as a result, you can watch these cells evolve, and as the statistics of the various boundaries in the system, because there's more than one, change, so does the identity of the associated object. Right? Which is really what I want. This is really all about labeling stuff. Right. And in order to label stuff by type, you need a blanket. And the way that you identify a type is by the statistics of the blanket.
Okay, this is really useful. Because, I think we found agreement with the idea that the FEP needs to integrate some historicity, some dynamics, and perhaps even changing identities, as you've just outlined there, Jeff. I think.
Yeah, well, I think the critical thing is recognizing, and this is implicit in everything that Carl writes, right? It just needs to be made more explicit, right? He says the blanket defines the phenotype. That is a misleading statement. It's true, but it's misleading, right? The correct statement is the statistics of the blanket define the phenotype.
Right.
Right. It's not just the blanket itself. That the blanket itself is just a domain.
Yeah.
Right. It's just where. Yeah.
Well, I think this is this problem, I think, has started to be remedied within the active inference literature, because I don't know if you guys have noticed this as well, but there's been a move to turn the internal generative model to a generative model that actually both encompasses across the Markov blanket the external or the internal states. So this is something that Maxwell Ramstead makes very clear in his in this year's paper, Physics of Belief, to put it roughly. But I think that there is still a slight point of difference here, and I wonder whether it's just a semantic one. Jeff, you still talk about internal states or the particle or the thing, the system and the environment, whereas Vicente is talking about coupled oscillators. And the way that I think about this is we can either have an intrinsic or an extrinsic relation between, let's say, external dynamics and internal dynamics. Now, what does that mean? Well, an external relation would be something like a causal relationship. So the A and B retain their identity despite the fact that they're causally related. An intrinsic relation is something more like a familial relation. Okay, if I am my mother is defined as my mother because of the relationship that she has with me. So in many ways, I find that this distinction that you guys are carving here might be neatly mapped onto that distinction. Vicente, I'm going to start with you. Do you think that a mistake that the FEP makes might be to try and carve out an external relation? So we've got A enacting, changing B, which changes A, when really the focus should be on the dynamics of the entire system as a whole, in the way that sort of Evan Thompson and those who followed spoke about these kind of coupled dynamic systems where the identity is in the mutual coupling.
Good question. I mean, I would like to just point out, I think Jeff has pointed out what our issue is, and I agree with pretty much everything he has said in that regard. Right, our issue basically was that, I mean, we have nothing against Markov blankets as a methodological tool, as a mathematical tool. But we would like to know more about how you select the blanket, because we think that depending on how you select the blanket you are interested in, you might be doing two different things, right? And that it's other fundamental parts of your theory what makes you to select a blanket, let's say, for the organism, and then the organism has internal states and the environment is the external states. Or if you are an ecological psychologist like me, you want a blanket for the organism environment system, and then everything is internal states, and it's not clear what the external state would be there, right? You can also choose a blanket on the organism environment system and a nested one,
and another blanket.
So
it's blankets all the way down, man. All the way to protons. They got blankets too.
So as a mathematical tool, so to speak, there are too many blankets, right?
Yeah.
But how you choose them reflects what kind of fundamental theory you have in mind. And when I say fundamental theory, I think about psychology, cognitive science, right? So if you, for instance, think that the organism has this input-output mapping and all the relevant computations happens inside, so all the control of behavior, all the perceptual inference is depending on the internal states, you are likely a cognitive scientist of the mainstream, right? And you want the blanket in the organism, and the external states are basically input, right? While if you are an ecological psychologist and you think that to understand perception, for instance, the first step is to see the structures in the environment, those structures are relevant in themselves and contribute to perception as much as the internal states of the organism there. So then you probably don't take those structures to be just input, right? So my point being here that I totally agree that there are too many blankets and that this selection process depends on deeper theories that go maybe beyond the free energy principle as such, and you can use the free energy principle as a method to develop those theories, right?
So this is my take on this is I completely agree, right? There is a sort of hidden additional principle, but I think that one of the reasons this got neglected in the free energy literature is because the whole point was, we're always drawing blankets. You can draw it anywhere, and this theory still applies, right? Doesn't matter where you put your blanket, right? I can still treat the system as if it is doing inference over its environment. It doesn't, that was sort of like I think the reason why the sort of additional, like, how do you select your blanket problem was neglected was because they were trying to show the principle always works, right? That's sort of my defense of Carl Friston's world, is that, like, there's a reason they skipped the problem, because it wasn't the important problem, right? The important problem was, it doesn't matter how you draw your blankets, you still can apply the rest of the principle. So if you decide that your system is a cell, that's fine. If it's a collection of cells, that still works. If it's and so on, right?
So our question was then, I think this question was in the Markov Blanket Trick too. What if your blanket is the organism environment system? What are the external states to that system that the system infers, so to speak?
If your blanket is like the whole universe, I don't know, I'm going to go with It's Christmas. I'm going to go with Baby Jesus.
Okay, very good.
Right? No, right. I mean, I think that's counter to the reason why we want to define blankets in the first place, and the reason is because we want to label things, right? And the reason we want to label things is because, well, it simplifies our lives, right? If I can look and say that's a cat, that's another kind of cat, right? Then I can sort of use those labels because they make my life easier, right? They make prediction easier about what's going to happen and things like that, right? That's the reason why we want to have labels. And the Markov blanket just sort of says, well, this is a potential place. So and the reason I make this argument is because I do think that implicit in the whole approach, while not necessarily as explicitly made in the literature as it should have been, is that the goal is to label things. The goal is to come up with phenotypes. And since the goal is to come up with phenotypes, you can ask the question, well, why would we want to do that? And the answer is parsimony, right? We want a simple, compact representation of our world. And the way we do it is by taking big, complicated things made of lots of little parts and giving them a single label that describes a lot of their general properties and features. And that is exactly what the Markov blanket does, or is capable of doing. And so that also tells you, which is why, like in my world, right, that's the additional principle. It was implicit. I want to make it explicit, that the way that we choose which blankets to focus on is like the way we do science. It's based on simplifying dynamics for the purposes of prediction and data compression.
Jeff, I may jump in here and perhaps speak on Vicente's behalf. I'm very happy for him to jump over me and clarify this. But I think a question comes up here, which is, so we're interested in labeling, we're interested in describing coupled systems. So how come when in the FEP literature we draw blankets, they so coincidentally happen to fall elegantly on what we intuitively believe to be things and their blankets? So, for example, yes, you say, okay, it's because, well, we see cats and glasses and humans and planets, and like, why wouldn't we carve blankets around them? But why, in a sense, does it work to carve blankets around them if we're dealing more in information exchange than how the object appears to our sensorium? And given that, as a mathematician or a physicist, what does that say about the mapping between kind of our perception and the information transfer that we're being able to describe via the Markov blanket?
I think very hard about that question. Because my knee-jerk response is to launch into my what is science for discussion, which is probably not going to directly address what it is that you want me to address. When the issue is still, if the issue is still let's see. So there are two things going on here, right? One is, what do we do with the information that the universe gives us? How do we categorize it, label it, and make it simple and easy to understand? And then the other issue is well, what is any subsystem necessarily doing, right? And those are very different issues, right? When we talk about when we ask the question though, why do we call this a subsystem and then I'm trying to cut it in half and this not and this not a subsystem, and that choice is arbitrary, right? That's one of the lessons that I'm trying to drive home here is that you can draw a blanket around anything. The question is, why would you? Right? Having drawn a blanket, all of the free energy the Bayesian mechanics all apply, right? But why would I draw a particular blanket? And it really is because it's useful to us, right? If we could just have a computer that simulated absolutely everything, right? And it was it cost 5 cents to run, we would totally do that. And we would be happy and we wouldn't care about labels, right? But we don't have that ability, right? We are trying to construct these, things that we can wrap our brains around. We're trying to simplify things, to make them parsable and understandable to us. And so that's why we would choose a particular set of blankets. Now, but again, the point though is, and the reason why I think that there wasn't enough emphasis in the free energy literature is that once you have established that there's a blanket, which you can always do, right, the rest of it just follows, right? All the stuff about, is it behaving as if it's performing an inference on its environment? Yes, right. I think the more interesting question that Vicente brings up in the paper, which I read yesterday, that I thought was a really great question, had to do with well, which is the environment and which is the object, right? Because even this parsimony principle that I just established, right, doesn't help with that. Because I just said simplify the global dynamics. What macroscopic theory does the best that happens to have this partitioning, and that doesn't tell you which is the. But this is where I think you now need to move back into physics land, right? So people I really like the work of Jeremy England, and everyone loves Schrodinger's little. Is it What is Life? Is that the title of it? Right. where there is, in that work, there is like a definition of there is a notion of how you tell which is the agent and which is the object and which is the environment, which is the agent and which is the environment. And it basically has to do with energy flow, right? So you could sort of say, oh, well, the organism is the thing that takes in energy and produces entropy, right? And that, once you've done that, if you're talking about a physical system, right, then now you have something that does in fact uniquely identify which is which you don't get out of it. Then this is my point, right? You don't get that out of a simplicity parsimony type principle, right?
Vicente, I'm not sure whether you want to
go
to that second point or whether you want to loop back to my first point about the mapping between the supposedly arbitrary epistemological tool-based approach of the Markov blanket and actually maybe how that maps onto logically, at least what we perceive. I don't know which one you want to start with.
Yeah, I think that the last thing, or this last intervention by Jeff, I think he states, and I think we are going to agree here. He literally states the Markov blanket trick, right? That as soon as you put the blanket on top of a system, right, or whatever you choose with all this pragmatic stuff, then you can do Bayesian inference, right? As you put the blanket, you have now so to speak, the data structure with latent variables, observables, and internal ones to do that. And I think we could agree that this is the Markov blanket trick, while Jeff thinks this is good, right? It's good. We think it's so, right? That kind of be the point, right? So I think the Markov blanket trick is good if you are already convinced, for instance, that perception is a kind of inference, and then it gives you very precise mathematical tools to model that. Now, if you think like some crazy people like me, right, that perception is not something that the internal states of an organism, the internal states of an organism do in order to know the external states, so to speak, but is a property of the organism environment system, then this data structure doesn't really map very well with what we want to do. Or maybe it does, but we don't see how. And part of our paper is to try to express, to state these doubts on, okay, how could apply this if I think this other thing, right? And then second part, which is why the blanket falls exactly where it needs to be. I think this is a part of a conversation I've had like dozens of times with Maxwell, right? He's the person I've talked more about this, so we've talked about this. And actually, in their commentary to the Markov blanket trick, they talk about this paper he has with Dalton, the weak Markov blankets, right? That they prove that there are a lot of them, right? Like as soon as you have dimensions enough, and our question in our response was, yes, I mean, but the point is not that you have a lot of them, it's how you choose the right one. So how you choose for, let's say, for the visual system, how you choose the blanket in the sensory receptors, so to speak, right? And I think Jeff has been touching upon that, right? In some of the things he has been saying today.
Before I move back to Jeff, could you just maybe for the audience expound upon what you meant by this sort of distinction makes sense when we take for granted perception as inference? I think that would be quite an interesting avenue just to unpick a little bit further, just so the audience knows exactly what you mean by that.
Yeah, so long story short, the common theory of perception, at least since Helmholtz, but most likely since Descartes or even beyond that, is that perception is a form of inference, right? So our brain is in the business of inferring the real environment, so to speak, from impoverished stimulation. So what we get in our sensory systems is usually ambiguous, not very informative, or not completely informative, and generally insufficient as to know what is the exact cause of that input, right? Like the typical example is that a small close object can give you the same input than a larger object that is farther away, right? They can occupy the same angle in your retina, blah blah. So the mainstream theory is that the brain is in the business of inferring the real properties of the environment from this impoverished input, and that's so because it can use prior knowledge, memory, experience, to build up a good model of the real environment. Ecological psychologists think, along with many other people that come at least from William James. William James explicitly claims that this kind of approach, this inferential approach to perception, is pure mythology. I mean, it's kind of the way they wrote in the 19th century, right? But the point being is that for ecological psychologists, the kind of prior knowledge you need in order for the inference to work is very difficult to justify. So they think that perception is more of a relation of rich information that comes from the environment and the internal dynamics, and the relation itself is what perception is. But we don't need an inference because we don't need to go from impoverished stimulation to the real environment. But there's a way to understand perceptual information that gives you all you need without the need of prior knowledge in order to get grips, so to speak, with the real environment. So it's kind of a direct and indirect stuff, or perception as an inference, or perception as information detection. Now, I have to put, again, because I've talked with Maxwell a lot about this, so I just want to put a sort of asterisk here, right? You can still see how the internal dynamics change in order to couple with this and reach information in terms of some form of Bayesian inference, because Bayesian inference is just, you can describe the path of a dynamical system towards an attractor in terms of a probability density of the state. So there's a form to use inference, that is the Bayesian inference way in which you can capture both of them. I'm still in an ongoing discussion with Maxwell about that. So.
Yeah, this is the as if part of the free energy principle, right? The math tells us that everything, right, behaves as if it is performing Bayesian inference, right? It doesn't tell us two additional things, like how shitty that inference is. It could be real, like a rock is performing Bayesian inference. It's just not doing a very good job. That just falls entirely from the mathematics of it, right? Is that it is an as if description, right? The description of anything, it is always an available description of a phenomenon that it functions as if it's performing inference, right? Whether or not it's actually performing inference or doing solving the right inference problem or however you want to put that, is not explicitly addressed. And I think a really interesting question is, so for example, when one applies the free energy principle in practice, there's always this implicit assumption that whatever the thing is doing it's actually doing inference correctly, right? There's an optimal inference engine sort of like hidden inside. Now they can get away with this, right? Because what goes on the inside doesn't matter, right? And what defines the object what defines the thing is the statistics of its boundary. And so if you have like a really boring boundary statistics, like you're a rock, right? Then you don't need a very sophisticated, like the inference engine that you would actually use to sort of say, well, what does this rock have to infer about the external world in order to be a rock? And the answer is very little. So you kind of get a lot of these things for free, but it is an as-if description, right? It's not like, it's just but like I said, this is, another way to get to the free energy principle is from a purely information theoretic approach, right? And I prefer that approach because all of this stuff makes a little bit more sense, right? You're not sort of saying like the rock is doing inference. You're saying, the rock is behaving as, it becomes more clear that this is sort of an as-if argument, right? As opposed to there's literally an internal state in the rock that is computing, the probability that the water in the stream is about to change. No, it's not, right?
Yeah, I had an
but only because you have to in order to be a rock.
Yeah. I did quite a good podcast with Adam Saffron a couple of days ago, and I said my favorite two words in the free energy principle are "looks like," but as if is that
as if is the one that I like to pick.
Yeah, as if looks like. No, I think that's useful clarification. Unless you're a panpsychist, and then they might be coming for you.
What's wrong with panpsychism? I don't understand why everyone's down on panpsychism.
Hey, I actually don't mind it. I'm kind of into the spookier versions, but I think
love it.
Well, they might be keen to. Perhaps I can't speak for Philip Goff and everyone else, but they might be keen to bring into question the validity of that as if or looks like. But we need not go there. I wanted to sort of. I do want to. This was one of the critiques that I kind of identified, so I do want to just get some clarity on it. And I'll actually quote Vicente here. So this is Vicente's response to the commentaries. The extent to which something counts as a thing depends on the choice of Markov blanket partition, which can be adjusted according to the needs of the model. There is an ambiguity here. On the one hand, it is claimed that things are what they are by definition, even if boundaries do not really align with the intuitive ones for ordinary things. On the other hand, when the FEP presents possible examples of things, like brains or cells, the Markov blanket always falls in the right place from the intuitive point of view. So that probably puts more elegantly the point I was trying to make earlier. Jeff, does that shed any clarity on where I was going? And Jeff, do you have a kind of riposte to that?
I almost hate to do what I'm about to do. Can you give me the quote one more time?
Yes.
My brain.
I'll give you the.
That was a lengthy quote, and yes. I'm going to need to hear it one more time to fully absorb and appreciate it.
So I'll do a sort of amended version, a shortened version. On the one hand, it is claimed that things are what they are by definition, even if the boundaries do not really align with the intuitive ones for ordinary things. On the other hand, when the FEP presents possible examples of things, like brains or cells, the Markov blanket always falls in the right place from the intuitive point of view.
Okay, so I do have a response to that. And that this goes back to the notion that what defines a thing, where you get this sort of notion of phenotype, is the statistics of the blanket. And so that gives you the ability to sort of say, oh, this is like, like right now I'm concerned with brains. So all I have to do is ask, what is the statistics, what is the statistics of the brain blanket, right? And then that's the thing I'm currently going to investigate, right? And so, but I do think that this does illustrate one of the issues which we've been talking about, which is that like there is this sort of fundamental, if you were going to like de novo start just putting blankets on everything in the world, right? There isn't an explicit principle present in the FEP that tells you how to do that. Right. There's this additional principle, which is like, that led to the algorithm that I used to discover the blankets of flames, which is like parsimony. Right. But it's not now the reason why that they don't worry about that is because the implicit in every single thing in the FEP literature is the notion that we are labeling stuff. Right. I have the freedom to label what I'm interested in. And having done that, right, that sort of tells me what the blanket statistics are going to be. I'll just add one other thing. The reason I prefer like the information theoretic derivation of the FEP is because the way that works is you start out with a probability distribution over blankets, right? It's like this is like and you take it's a Jaynes max cal or max ent kind of approach, and you sort of say like, hey, like I have some laws that tell me how the universe works, and those are some constraints, right? And then I also have I want to find some subset of my system that has these statistics. Those statistics are then definitional. This leads to, sort of Langevin equation-y type things, right? That you can then solve, which tells you how the world has to be, how the individual particles in the system have to behave if you're doing it in particle space, in order for that thing to exist, right? And it has to exist because you imposed it as a constraint when you did your sort of max nt thing, right? If you have that in mind, what you're really asking when you take this sort of FEP, if you take this sort of, can I use the phrase ontological potential, or is that going to make people upset? Right. One of the things that comes out if you take this sort of the approach, you're basically like, look, these statistics define an object type, right? And now what I want to know is like, well, what's inside, what's outside, like what kind of environment it can live in, like what kind of what does it have to be made of, right? You can just apply those statistics as part of a constraint, do max ent, and get all of the equations that tell you what kind of environment this sort of thing can live in, right? But the starting point was like, I'm interested in like this kind of thing. Right. And the reason why we call it an ontological potential is because you sort of said like, you've started by saying, this is my definition of something. And free energy is literally a potential function. Like when you do it in this max nt way, it's literally a potential function. So free energy is an ontological potential. But it does start by saying, this is the thing I'm interested in. It starts by specifying the statistics of a given object type.
Vicente, do you want to add anything to that? I mean, I'm wondering whether if you're putting your philosophical hat on, what presuppositions, just that kind of, as Jeff said, like we're starting from like, this is a thing, what philosophical presuppositions does that entail?
Yeah, I mean, I'm kind of happy with that. Right? You choose your thing, and you apply the methods you want to. So we really don't have anything. When I say with the authors of the paper, of course, but myself also, we really don't have any criticism to that. Our criticism, and actually it was that paper was published along with a few more that were talking about that. There's this one by Jelle Bruineberg et al. On the Emperor's Blanket, and Miguel Aguilera and Chris Buckley had another one there, right? So to speak, if you are upfront with, look, this is what I take to be a thing, or this is my thing of interest for these reasons, and then I'm going to apply the Markov blanket here. If the methods work, go, like, cool. The thing is that sometimes in the literature, these extra steps or these parts are, as Jeff have said, not explicit enough. So it seems that everything falls from, you ask what is to be a thing, and then you have a full theory of cognitive neuroscience. And we are like, we don't think so, right? There are other deep ideas at work there, right? But if we go back to that quote, it's also not about the kind of the general possibilities of the free energy principle and active inference and the Markov blanket formalism, but more about how it is presented in the literature sometimes, right? So sometimes it is clear that you put the blanket, so to speak, in the phase space, not in the real space, but in you select some states, and then you put the blanket there. And this is clear, for instance, in one paper, I think it's Michael Kirchhoff, Julian Kieberstein, Carl Friston, and I don't know if I forget someone else, but they actually model coupled pendulums, right? And the blanket states there were something, I'm not completely sure, but were something like velocity and acceleration or position acceleration. These are not the intuitive ones, right? This is not the surface of the pendulums, so to speak. But then when you go to any figure in the literature, you see the blanket that is in the sensory receptors or in the membrane of the cell. When you expect the blanket will be from an intuitive point of view. So our point is that these two claims seems to be not very well aligned, right? Either you find the blanket in an abstract state of space, or in a space of states, or in an n-dimensional states of space, and then the blanket can be velocity, acceleration, jerk, whatever you want, right? Or you go to the more intuitive way in which the blanket of the cat is, I guess the hair or something like that. Or you find a way, which I guess is the ultimate aim, right? You find a way to align these two, maybe.
But I think the reason that this happens, though, is because the principle is uniformly applicable to all systems, and and all subsystems and all subsystems of subsystems, they kind of like glossed over that problem. It's like, doesn't matter what system you're interested in, this theory applies, right? And I think that's one of the reasons why, like, the issue that Vicente brings up was basically glossed over, right? It's because it wasn't, the two interesting questions, from my perspective, that got glossed over are, how do blankets form in the first, how do the blankets that we would like to call blankets, because there are blankets everywhere, but how do interesting blankets form, right? What are the mechanics that lead to that process? And then why do we say this is an interesting blanket and that is just a drop of water, or just a fluid volume? Blanking on the easy stuff now. Why is that just a fluid? Why is that an uninteresting blanket? And this is where the whole like parsimony thing comes in, right? Interesting blankets have interesting properties, right? And they simplify the overall dynamics. But if you start out your paper by writing that, like, oh well, I'm going to have this other principle, and it's going to say this is a blanket and this is the preferred blanket, right? Then you sort of it kind of tarnishes your ability to say that your theory is uniformly applicable to all systems and subsystems. And I think that is ultimately the cause of this of this particular confusion. Which is why, like when I saw this stuff, my knee-jerk response was, why are they saying a flame doesn't have a blanket, right? So I should mention the title of my PhD thesis was like, what was it? Complex dynamics and solid flame microstructure.
Oh.
So actually burning stuff.
Oh.
And the way that we model flames is explicitly with a blanket. The blankets, is the flame. It's burning this way down a fuse, like this. Think Acme bomb, right? It's going like this. It's going down a fuse, and there's a blanket, right? The blanket is basically just outside the reaction zone, right? In the same way that, like, fluid flowing or air going by like an airplane wing forms a little boundary, which we call, curiously enough, the boundary layer, right? And that's a blanket too. We are constantly using blankets because they simplify dynamics. And that was exactly how I got to this, that's exactly why, to me, that there was this implicit parsimony principle that solved that particular problem.
Excellent.
But I certainly agree. Like, it was a rhetorical choice, right? You want to show that it always applies. So of course I'm just going to randomly draw blankets as need be, because it always works.
I like that. In the I mean, in the spirit of generality, they kind of gloss over these tiny details that there are some systems that might be tricky, right? But I think there's kind of another reason for that. I don't think it's an opposite one. It's a complementary one, but and it's a reason that I think applies mostly to psychology and neuroscience. Like Jeff, I'm not a super fan of what they call the high road to the free energy principle. Yeah, the random dynamical system plus that. I like better the one that comes from predictive processing and builds up, right? First, because I think it what happened historically, right? With the
Yeah.
1990s paper on autoencoders to, and you can see that. And then because it makes explicit how the free energy principle within psychology and neuroscience grows within a theory, within an overall theory in which this separation is already taken for granted, right? You see, there are the internal states of which are the brain that are making the inference. There are some blanket states, right, which are receptors, and there's an environment there. So right, this kind of blanket formalism perfectly fitted the overall idea that there we have internal states that have to infer the external one. So it was not an issue for kind of, say, the mainstream psychology, neuroscience to think in that way. It was like taking for granted, so to speak. But then there's this weird people called ecological psychologists that have issues with that thing, and of course that's the place from where our paper comes, right? We see issues in some systems in that.
So I'm going to propose like the happy middle ground here, right? So the statement that all things behave as if they are performing inference is kind of hard to get around, right? Because like it literally follows from, I mean, it follows from whether you take statistical physics or information theory. It's sort of a statement about like but what it doesn't tell you is the thing that is what it doesn't, and so now you say, well, I don't think that the brain is doing inference, or I don't think perception is inference, or something like that. It turns out that's not incompatible with what the free energy principle states either. And the reason for this is because the free energy principle says that all things behave as if they are performing inference. It says nothing about the quality of that inference. It could be really shitty inference. It has to be good enough so that the thing can maintain its boundary statistics, the statistics that define it as like that type of a thing. But it could in fact be really bad compared to what a normative model of inference would be performing. And I think this step has also been sort of, or this little bit has also sort of been missed, right? There in a lot of applications, because like, especially like what I do nowadays, which is like, AI applications, you don't want to find systems that do shitty inference, right? You want to find systems that do optimal inference, right? And so, but in practice, right, that becomes the new question. It's sort of like, well, okay, so they've shown that it's always doing inference, and I'll just accept that, but I don't care. I don't care because I'm interested in the exact in the kinds of inference mistakes that it's making, right? It's kind of like saying, like when we're in the lab, right? So I've worked with a lot of behavioral scientists over the years, and when they're in the lab, they always sit the monkey down and okay, let's not do monkeys. There's a mouse, and the mouse is doing some task, and we always want to ask questions like, well, how well is the mouse doing this sort of like this task? And we can solve that problem because we designed the task and we set the mouse to solve it, right? And so we can sort of say, oh, well, he's getting like 95% correct, or let's say he's doing 90% correct. But the maximum he could, given the task difficulty, the best he could possibly do is like, 98% or 96% correct, like that. So that's comparing the animal's behavior to optimal behavior. And we do that a lot in the lab. But when it comes to really complicated things, we don't have that, we lose that ability. right? And this is where cognitive psychology comes in, right? Cognitive psychology is like, okay, there's no way in hell a human is going to solve this really complicated social dynamics problem optimally. In fact, we don't even know how to write down the solution to this really complicated social dynamics problem properly. Now, you might be able to say from this free energy perspective that the person is behaving as if they are solving it probabilistically or as if they are doing inference, but it's not optimal inference. And so now what becomes the interesting area of investigation? The interesting area of investigation is, what are the mistakes that someone is making? How do we characterize those? Like, how do we just characterize their behavior, right? We don't have to, if you're a psychologist, you don't have to commit to this as inference problem, right? Because the question that you want to answer is not, is it doing inference, but it's what sort of mistakes are you making? What sort of assumptions are you making? Not, which is a statement about the quality of your inference algorithm, which is much more interesting than whether or not you're doing inference. I think that was way more long-winded, so I apologize. I meant that to be compact and concise.
Not
it just didn't happen.
It's a really useful addition. So backtracking 15 minutes just for the audience. The paper that Vicente mentioned is, I believe, Kirchhoff and colleagues, 2018, the Markov Blankets of Life. I like just clarifying that in case people want to backtrack. And
I believe that's the Blankets of Blankets one, right?
Yeah, that's the one with the pendulums.
So I wanted to
clarify that. Okay, this is interesting. I mean, again, we're getting on far too well. But no, we're doing well. No one's shouting at each other yet. Okay, no, this is super. So as you said, Jeff, we kind of need to do approximate Bayes sufficiently well that we don't dissipate into the heat bath, or it looks like we're doing that. And that's, I feel like some of the ways that issue got skirted is that we would encode a higher order, if we're talking about humans, a higher order prior preference that we believe that we should be, or we are minimizing variational free energy. So there's is that like kind of well, go ahead. I'm just curious about your thoughts.
We don't have to believe anything about this, right? A cell doesn't have to believe in the free energy principle. The point is that it's a mathematical inevitability, right? So I guess, okay, so let me go back. There are two ways to think about the free energy principle, and one of them has to do with like self-organization. So what does self-organization mean? It's sort of like, it sounds as if you're sort of saying that, like, oh, I have a notion of self, right? That I act I take action so that my notion of self is coherent. I don't like any of that stuff. I know that a lot of other people do, but I don't like it because the whole point is that you don't even need a notion of self, right? In order to behave as if you have a notion of self, right? The way it's constructed, it's sort of like, oh, okay, it has a boundary. The boundary has these statistics. What simply has to happen to maintain those statistics? Those statistics give us a notion of object type, which you could call self. And you could sort of say, well, okay, for now, then you could sort of ask the question, well, like, inside, does it also have this notion of self? I don't think that's a meaningful question, right?
Yeah.
It's sort of like, well, we've said like this, this is the object type, this is its definition, and we're really asking a question: how do internal and external states collaborate in order to maintain the boundary? And sure. if you take the max enti, version of the derivation, that becomes explicit. What you're really asking is, how do internal and external states collaborate to maintain boundary statistics? And It has nothing. There's no notion of like self.
Yes, I'm completely on board with that. I do. Some of the work that I like to focus on is actually about self-modeling, self-construction, which completely is opposed to the Cartesian ego picture. And I think actually a lot of the conceptual problems come from a retention of the Cartesian ego, that people just feel it's very difficult to abandon that picture. No, I was only adding this because, well, what you said is very much in line with what Carl said when he came on, which is that there is no real existential imperative. It's just, if you can see object X at time here and object X at the same supposed object at t+1, they've had to have done something that looks like a Bayesian inference. So it's an existential imperative only in the sense that we can kind of say that things persist through time. But there are these sort of added bells and whistles, right? So, I'm pretty sure there are papers, now maybe these are earlier papers, which say something like, I read it today, there's an a priori belief. Now, whether this is a propositional or subpersonal belief, I think is somewhat trivial, that I am, and again, I'm saying this to make sense, I am the type of thing that will minimize variational free energy. So, given that, but given your point that we can do quite shitty variational Bayesian inference, perceptual inference for one, and our KL
relative to optimal, but yeah,
right, our KL divergences can be quite big. What, Vicente, do you see a way of accounting for the persistence of the organism beyond just like this slow optimization problem, which, as I said, kind of historically at least invoked this higher order prior that I am the type of thing that will do descents down free energy gradients?
Away. Well, I mean, I guess this is a question on how do things persist in time, or how what we call things persist in time. So one thing is that I don't have any issue with the mathematical imperative part of it, right? That's part of. I mean, I can say something like, given these and these constraints, the dynamical system with an attractor will tend to that attractor, and that's a mathematical imperative too, right? If you have an attractor and with the constraints may be, the system will tell that. And actually, you can redescribe that tending towards the attractor in terms of Bayesian inference, in terms of self information minimization, or whatever, or maximization, and free energy, right? So I don't have anything about that. The thing is that the way the permanence of things, or the self-organization of things without the belief of it, has been studied in time, is the kind of thing that touches on homeostasis, allostasis, or even autopoiesis, right? An activist think that the thing does is to self, not only to self-organize, but to self produce itself, right? So to speak, the internal state of the systems are engaged in maintaining the boundary, right? That's what they do there, and I don't think they picture that in terms of having to believe that. They basically picture that in terms of catalytic or even physiological ways to maintain that, right? And I guess that's an account of homeostasis too, of allostasis when you include the dynamical relationship with the environment, right? So now I guess the question is that to what extent, or the question we were interested in, is to what extent this physical imperative of the minimization of free energy, or the performing as if making Bayesian inference, is able to capture autopoiesis, for instance, right? And not only autopoiesis, not only the self-organization part, but the self-production part. And that's another question we have in there.
Yeah, so I have two answers, right? The first is that when it comes to like maintenance is baked in, right? If you say my definition of a thing is that it has these boundary statistics and they're stationary statistics, then it's baked in, right? Which is totally fine. That's your definition of that object type. It is stable, right? And that, which is great. The hard question, and the question that that has been, I think, that has gone largely unaddressed in the FEP literature, is how do these things form in the first place? And this is right, like, when you say like, oh, it's a the focus has always been on homeostasis, which has nothing to do with starting from a glob of goop, right? And getting something that is stable, right? It doesn't have anything to do. Now, there's self-repairs in there, right? And there is like finding, homeostasis balance with your environment. But there's nothing that is, how do I get from, a chemical soup to a cell? That is, the FEP has historically, been completely agnostic on that topic, right? And that's one of the reasons why I don't use words like, allostasis. I also forget what they mean because that's a big word, a really big word. But that said, there are in fact people working on that particular problem. And that's why I like to cite, so I've mentioned Jeremy England like twice now. He gets a third mention. That's how cool I think is. I also just read his book, which was a lot of fun, and this is probably why it's on my mind. So the approach that he's taking is, well, okay, so that's the goal, right? The goal is to say, well, what actually, why is it that these complicated things form apparently out of nothing? And the math that he uses is in fact the mathematics of statistical physics. And the thing that and the mathematical object that seems to motivate this is constructing free energy minimizing flows, right?
Great.
He even has I think it's chapter 7 in his book, where he then goes on to say, and by the way, you could think of these free energy minimizing flows as doing a kind of computation about their environment. But he doesn't actually say as if. I actually read through it twice just to see if he used the phrase as if, and it turns out he doesn't, which is unfortunate. But he makes a very similar argument, right? Is that this free energy minimization principle can in fact also lead to the formation of these things. The math is a lot more complicated, right? And certainly static blankets don't apply in this scenario. Like a static Markov blanket doesn't apply, right? Because the whole point is that over time it's actually forming. The blanket is constantly changing and morphing into a much more interesting set of statistical. So the statistics of the blanket are no longer stationary. So a stationary blanket doesn't. But the same free energy principle applies. The same free energy principle that Schrodinger called negative entropy, or that was sometimes referred to as negative entropy. And the reason for this is because it all falls out ultimately from like statistical physics.
Okay, fantastic.
But you're right. That has not really been. I mean, I just wanted to reiterate. I did have a point when I started the tirade. I just want to get back to it. It is true that hasn't been addressed. Like how these blankets actually form in the first place. Is the free energy principle in its current form has been largely agnostic, and that's why we say, well, take a look at what Jeremy England's doing. It's basically free energy too.
Okay, I'd like to get to that maybe as our sort of closing remark, because I don't think there's going to be too much antagonism or discord there. I will raise one more criticism that was mentioned in Ezekiel de Paulo's commentaries. So this is his criticism of the FEP, and then we can move on to the fluffy philosophy or statistical mechanics, or whatever it is. So Ezekiel de Paulo has two critiques in a way of this of the FEP formulation. The first is exactly what we've spoken about, which is that we have to make a choice about where to carve up the Markov blanket, and we've covered that until the cows come home. Although I'd be always happy to return to that. But his second point is, and I will quote, Markov blankets are too strong to account for the way the internal states of an organism are often directly affected by external states without any statistical mediation or loss of integrity, as anyone who's ever been tipsy after a few beers or felt dizzy from heat exhaustion can verify. So now we've gone to a completely different formulation, which is just no vicarious blanket states. Okay, we're having direct effects. Jeff, I'm going to start with you because your face is telling me that you don't like that so much. How does that sound to your ears?
I'd have no idea. I have no idea what is meant by that. It's sort of like, I mean, and certainly the analogy that was provided, I do not understand. I suspect that either, I mean, I'm probably being obtuse, or maybe I'm not tipsy enough, given the analogy. But I don't understand how anything can have a direct effect. I mean, I can think of another scenario that one might appeal to make a similar argument, which is like, and now let's talk about like protons and electrons. They have electric fields, right? And those fields have, an effect, right? But to my mind, that just means your blanket is the field, right?
Yeah. Vicente,
So,
do you have any thoughts on this?
I was imagining that Jeff was not going to like that, and I do understand why, right? I mean, it's kind of in the very definition of a Markov blanket is those sets of states that are always there, kind of, mediating between the internal and the external. I guess that what Ezekiel was trying to point out there, it's something like it is possible for those blankets to be leaky sometimes. I think this is an idea that you find in the weak Markov blankets paper too. That there's no absolute fusion, so to speak, between the internal and the external states, and that's why they are weak, right? Kind of, there's not a full encapsulation. This is just an speculation on what's Ezekiel point there, right? That those blankets maybe can be leaky in some way sometimes.
Yeah, maybe this is an issue that I have difficulty understanding because I've already moved on beyond, in my thinking, like blankets don't have to be static.
Yeah.
Right? Because the best criticism of the original set of Markov blanket stories was your definition of a blanket, or at least the way you are using a blanket, prohibits matter transfer between object and environment. So like, good luck describing something that eats.
Things change.
Right. So fortunately, the way around that originally was to just sort of say, oh, well, we could have like made the blanket operate on fluxes instead of particles, and I never really liked that. But now that we've gotten this issue where we basically said, oh no, look, dynamic blankets, it all still works, right? All the math still works out just fine, even when there's matter transfer. It works on flames. And so if that was the ultimate issue, then I would say that issue has been resolved, but I would understand why someone would have drawn that conclusion from the literature. Because the literature focused on problems that were a lot more solvable. Like the identifying dynamic Markov blankets is a really mathematically challenging problem.
Yeah.
Whereas specifying a static one makes your life really easy.
Yeah.
And you should never be overly critical of people, in my view, for simple mathematical simplifications, right? You should always be generous and say like, oh, I understand that that's not part of the principle per se. That's just the particular use of it. And my favorite example of this is like general relativity. The equation of general relativity has like 3 terms. It's like big G, little g, and T. What they don't tell you is that hidden behind those 3 terms is a shit ton of math, which is why there's only like one solution to that problem, right? And the same sort of goes for the free energy principle, right? If you actually write down what the objective function for active inference is, it's really hard to compute.
Yeah. Yeah.
And so they made a lot of assumptions to simplify the math and to make the computation easier, right? And so I always encourage people to be generous with evaluating things, in which there are equations and then there's simplifications. If you're evaluating the theory, you got to evaluate the original equations, right? And not criticize the simplifications.
Very Christmassy. Maybe this will help or not, or maybe it might muddy the waters. Another quote now from the Markov Blanket Trick. Without the Markov Blanket formalism, the dual information geometry would be reduced to its intrinsic component, which is the only one needed for standard thermodynamics. And I've written next to that on my notes, why don't we just use this? Jeff, why don't we just use this?
Because I really do think, because like at the heart of a lot of this is like phenotyping.
Mm-hmm.
It's sort of like the goal is actually to segment the universe into smaller understandable pieces, right? And since if that's the goal, then that's sort of, I feel like I addressed this before when I said, like, if we could model the whole universe, like, no problem. Like, why would we bother to chop it up into little pieces and sort of say, oh no, this is a car. I'm going to summarize car dynamics. I'm going to worry about the little bits and pieces inside. Because why would you do that if you could just simulate the whole thing and it was no problem? Right. So there's sort of an empirical question here. It's like, that's why the reason we divide things up, the reason we draw blankets around things is to make our ability to understand the universe more tractable, right? Is to make it easier to get, right? The reason why, it's like you could always simulate everything if you could. You really can't. But like if you could, you would. But you can't, right? You're looking for cognitive shortcuts if you're a cognitive scientist. If you're a scientist, you're looking for simplifications of complex systems. You're looking for macroscopic variables. It's sort of like there's an empirical reason why you do that.
Vicente, have you got anything to add? And maybe I should have asked exactly what this claim entails, what the reduction to an intrinsic component actually looks like.
Actually, that was I wouldn't say a quote, but that was verbatim almost from the dual geometry papers, right? So it was more than focusing in the reduction you could do. I think what the free energy principle proponents are saying, they're like, look, this is just thermodynamics extended a little bit because we have this blanket that allow us to do this other thing, right? So that's what thing. And actually, I'm going to one more time agree with Jeff in many things. And I think that again, that was kind of the spirit of the Markov Blanket Trick, to try to go ourselves through other things that you need for the whole building to be built, so to speak. And of course, you need to choose the thing you are interested in. You need to make assumptions on, okay, these are the variables I'm going to be working with. And with that, I mean, ecological psychologists are pretty much the first people that during the 80s started using dynamical systems theory to model behavior. Actually, there's a 1987 book by Peter Kagler and Michael Tarvey called Information, Natural Law, and Rhythmical Behavior. If you go there and read how they gather from statistical physics and all that stuff, you see many similar points than you see now in the free energy principle realm, right? But the point being, when I say, okay, we model, or that within this kind of dynamic cognitive science, there's a very famous model, the HKV model of couple oscillators, in which the main variable is relative phase. Why is it relative phase? Well, it's a variable very easy to track, and when you track it and you model it, you have a very cool two attractors for these parameters, and you change and you see how the two attractors go to one. So you can express the qualitative changes of the coupling of the two oscillators in a very simple way with just one variable. And but why you pick that one? Well, because it's easy and it models it well, right? So I mean, I obviously agree with Jeff on that. The point was, yes, in the literature, these simplifications sometimes are not clear, and
yeah,
it's good to I think they and I also understand, Jeff, they are not clear because the aim was generality, right? So we want this to apply to everything. So when the couple oscillators guy come, but talk about my thing. Oh, okay, to talk.
That's right. Yeah,
we need to put all these other things as to make it work, right? So yeah, kind of thing.
Yeah, and that's one of the reasons why I really got to get this paper out. So basically, it's if you another way to think about what the Markov blanket story is that it's an integral component not just of systems identification theory, but also like macroscopic physics discovery. Right. So why did you pick the phase difference? It was a convenient variable. It encapsulated all of the dynamics. Right. What if your problem was I just have a complex system and I don't know and I need to discover what the phase variables should be. Right. And the Markov blanket story is one way to do that, right? It's sort of like I want to segment my complex system into different subsystems. And if you have a Markov blanket discovery algorithm, right, then it sort of does that for you. It does macroscopic physics discovery. It identifies that was the simplest variable to use.
That makes me wonder out of the bloom. So I don't have an answer to this. This is a pure question that might not have an answer. When people who work with dynamical systems, or at least part of them, to model motor control, right? They gather a lot of ideas from Bernstein and from Haken, and the idea of synergy, right? Like the brain is able to control the arm as a synergy because it's already coordinated as a whole unit there. Could you put a Markov blanket on a synergy, so to speak? I don't know.
So I think that so to some extent, and I'm going to just sort of say this is a gross generalization of what the blanket discovery algorithm does, but in a very real way, right? It's doing dimensionality reduction, right, which is basically synergy identification, right? So why is it that I can just sort of look at all this complicated stuff I can do? Well, it turns out, right, there's really only like a very small number of variables I have to track because they're all correlated. Right, there are restrictions or they're constrained. Right, my wrist is the same distance from my elbow, and so on. And so that's another way of characterizing. Well, that means they're correlated, right? And synergy and correlations are related. And so to some extent, what the algorithm actually does, or when you're doing Markov blanket discovery, what you're basically saying is what's correlated. What aspects of the dynamical system are sufficiently strongly related that I can reduce them to a single variable. Right. So, for example, for rigid body, right, I can describe this whole thing by 2 points, right? Because I don't have to model every single molecule in my arm, right? I can reduce it to a single variable, and that's another way of thinking about, again, macroscopic physics discovery, right? But I also think that's one of the reasons why, the FEP, as it's formulated, is strongly tied to just empiricism. Right, it has a lot to do with just how we do science. Right, we're doing dimensionality reduction and looking for principles that uniformly apply, and I think that the focus of the literature has been on the uniformly apply thing, and now we need to bring it into the real world of empirical inference, where it's the dimensionality reduction thing. But they are in fact completely compatible.
Amazing. Just again to loop round to what I had said so that people know where to go, the quote that I chose is footnote 12 of the Markov Blanket Trick. I told you I read the paper, and I think it pertains to this two complementary ways of describing the density dynamics of internal states, one being this intrinsic change over time towards the attractor state, and then the other one is this extrinsic tracking of external states. And I'm not a mathematician, but it appears to me that the maths seems equivalent. And we can actually make a kind of formal equivalence between those things, which is quite beautiful, actually.
It's almost as if they're equivalent.
I'm not a mathematician. Give me a break.
No. Sorry, that was not a criticism. That was a terrible joke.
Oh, okay, fine. Oh, right. Yes. Very good. Very good. It looks like they're the same. Yeah, excellent. So I will finish with what I promised we'd finish with, which is a kind of bigger, potentially philosophical question that expands beyond the scope of the free energy principle as is right now. And this is an issue that actually really matters to me. When I first discovered active inference, I remember tweeting two things. One of which was the presence of Markov blankets upon Markov blankets is the best argument from creation that's ever been. And the second one was, I I think that the apparent distinctions of internal and external states mediated for a Markov blanket might itself be an illusion, and there may just be some sort of singular reality. I'm paraphrasing my silly tweets. But it was more just philosophical, ethereal thinking. And we mentioned panpsychism earlier. And again, I don't want to get too into the weeds on this, but Jeff, maybe we could start with you. Where do you think this all comes from, these distinctions that we can carve for instrumental reasons, which seem to, which do work mathematically? And what are your hunches about what might lie underneath them?
I love questions like this, and I have the perfect answer. So what lies underneath? Nothing.
Oh, that
was my serious face.
That doesn't help.
No. So I remember one time I got asked a question. Like, so we're talking about like, P's and Q's, because that's what you're doing when you're doing probabilistic reasoning. And somebody raised their hand. It's like, is there a true P? The answer is no. No, there's not. And it's not because there isn't a true P, right? It's just I don't understand the question, right? It's sort of a jerky thing to say. I often describe when I get, so as you might imagine, given what I do for a living, I get asked questions like that all the time. And I usually refuse to answer. And the reason I refuse to answer is because I got up to work today. I put on my coat and tie and I put on my work pants, right? My work pants are my harsh instrumentalist pants. And if you want me to answer like philosophical or religious questions, it's like, well, I have to put on a different pair of pants, right? When functioning in this environment, like, I take a very, very instrumentalist view, right? And I think so you asked like, oh, do we carve, is it all just one thing, right? Are these artificial carvings the artificial carvings are artificial, right? We carve up the world because it's convenient, right? Because it simplifies the problems we have to solve. It has predictive power and empirical utility. I like to say that science is not about truth. It is about prediction and data compression and nothing else, right? So when functioning as a scientist, that's what I focus on, which is my way of saying like, that's my answer. Harsh instrumentalism. Harsh instrumentalism means you don't have to worry about like what's true.
I can't wait for all the philosophers to be shouting at you virtually. Vicente, what are your thoughts on this?
I was expecting this answer from Jeff because my preparation to this podcast was not to reread my own paper, but to watch another podcast on the machine learning street talk, I think. And
yeah,
in that he was saying, electron is just the name for an equation, that kind of stuff, right? So I was expecting harsh instrumentalism. I'm kind of an instrumentalist too, in some ways. But at the same time, I'm a realist. So how can that be the case, right? I get it comes overall comes all to a form of pragmatism in the end, in which you can be realist about the kind of things you do. And if they are successful, well, you are dealing with the real world, and you do so by using instruments. And I'm in favor of a plurality of instruments. And Markov blankets are one of them that I don't personally use in my own research, right? But you can use it. But I wouldn't try to find a final foundation, like, oh, there's only one thing, or everything is such, or everything is such other thing, right? It's more like we act around, and reality is somehow the way where all our actions converge. And not actually, sometimes do, sometimes don't, and we carve reality in that way, and all we have is our concepts that are instruments and are not foundational in any way, tools, Markov blankets, other tools, and we go like that. But I mean, I do think there's some form of matter of fact or fact of the matter, so to speak. So there's something some reality that we build up together through action, and it's there. It's just, it can change, so it's not the final thing. It's not the an old philosopher, an ancient philosopher would say something like the arché, right? This final original thing. There's no, but there's a thing we do. There's a matter of fact, and the variety of tools and their superposition and their ubiquitous. I don't know that word in English, but even the things that they don't match well tell us things about what kind of thing we can do and we can do.
Oh, where are my Buddhist friends? Where am I?
Well, so that's the funny thing. You asked the wrong question. If you wanted me to put on my Quaker Buddhist pants, I can do that too.
Oh,
I just generally refuse to.
Maybe on Christmas Day, I'll ask.
Yeah, it's one of those. It's like I remember one of the faculty in my department when I was getting my PhD once said that philosophy is a lot like algebra or going to the bathroom. It's just not something you should do in public. And I don't agree with that. But I think it indicates like why it is I hesitate to answer these questions, because I don't really have good answers. I have my answers, and defaulting to instrumentalism is like just the easy way out, right?
Sure. Well, yeah, they're purposefully quite provocative and probing, but people seem to like answering them. Chaps, that was tremendously fun. Maybe we could have just a couple minutes for closing remarks, given we've reached such a beautiful point of conciliation. Vicente, maybe in addition to sort of closing remarks, you could also let people know what you're working on and where they could reach out to you if they wanted to know more about your topics of interest.
Mm-hmm. Okay, so I'm going to start by talking one last time about the Markov Blanket Trick. The paper kind of grew on its own. It's way long. I think it's 24,000 words, so it's way longer than I was expecting. Because actually most of it is just me asking a question. No, not me. We all of us, right? But asking the questions we have, right? Oh, but if the formalism work, why this and why that and why candle flames and why that kind of thing. But I really don't have a strong position on those things. I just would like to know, okay, how would you apply this to a model with relative phase? And that seems to include the whole system. I only have a strong opinion with one thing there, which is the fact that for perception you need or not need prior knowledge, right? That's actually the real my real stake there. Like, I think every time you endorse the system with some prior knowledge in order to make sense, to go as we talk from the impoverished input to the real world, so to speak, you have no way to justify that knowledge or to explain why it is there, right? The typical way nowadays say, no, it's evolution, right? But it's kind of unsatisfactory for many things. I don't want to go to this thing, right? But this is actually my only kind of my deal breaker. I think theories of perception shouldn't appeal to prior knowledge to explain it. And I think one theory that does that is ecological psychology. By virtue of the lawful relationship between the patterns of light and the environment, you have in those patterns of light information enough as to know exactly to a good degree what the real environment is, without the need of pulling other kind of knowledge into the equation. And I work on that, right? So part of my work is trying to make sense of cognitive neuroscience that starts with ecological psychology. For instance, if the brain is not in the business of inferring the real causes of impoverished stimulation or of enriching impoverished stimulation with other knowledge as to build a model of the environment, what the hell is the brain doing, right? So within the ecological approach, the word uses resonance. The brain resonates to this richer information. And part of my theoretical work is to try to operationalize the resonance metaphors, so to speak. So how can we have a concept that we can actually test? And part of my empirical work, I'm kind of maybe 70% a philosopher, 30% a cognitive scientist, cognitive neuroscientist, is to try to test that. So this year I've been in the B-Mobile lab, which is at the Technical University of Berlin, and they specialize in mobile EEG. And so I've been gathering some multimodal data that has, eye tracking, motion capture, and EEG to try to find what kind of patterns of information our brain can be resonating to. So how the brain dynamics can be constrained by these specific structures and not just by kind of say simple input and that kind of thing. So I'm trying to, last sentence, I'm trying to do something like ecological neuroscience, both in the theoretical realm and the experimental realm.
Very cool. Very cool. Jeff, go ahead.
So I'm taking the exact opposite approach. I'm trying to see how far we can push this whole prior thing. I like to joke that the difference between a Bayesian and a non-Bayesian is honesty, right? Is that you have priors, right? I don't know where they come from. I don't know that they're normative, but they're there. You're kind of stuck with them. All knowledge is like Laplace. All knowledge is based on, all knowledge is probabilistic, right? It's always based on assumptions. There are two sets of assumptions that are critical to worry about. One is, I'm going to get to what I'm doing in a second. One is the data, right? Any conclusions you draw is conditioned on your observations. But there's another important thing that we often forget about, right? Is that all of the conclusions you draw are also conditioned on your models for the universe. And I say models, this is just my view. I can see Vicente's going, oh my God. No, when I say models, I actually think the most critical thing that we often neglect when we talk about the Bayesian brain is that there's not one model. There's a lot of them. And you don't just use one at a time, right? You use lots of them. In fact, you could even think, and this is very coarse. I literally am going to get to what I'm doing in a second. It's very coarse, but you could think of a Bayesian brain as having brain regions, right? And don't overparse this, because I know people will, right? And each region is a model, right? Each region is a statistical model of something. And when you get a new task, what do, right? Well, you have to figure out which collection of models and how they're connected, right? Are the ones that like solve your problem, or model the data, or describe the data, or compactly summarize this, like the data compression, but compactly summarize the information that you received, or give you the predictions about the things you care about, or however you want to phrase it. And so what we're trying to do right now is we're exploring the extent to which we can get this to work at scale. So we want to construct a brain that's not like some fast feed-forward neural network, right? But one that is more brain-like, right? By saying that no, brain has there's lots and lots and lots of models, and the way that the brain actually attacks problems is by reasoning by analogy. This model explains this part of what's going on. This model explains this part of what's going on. And the trick is, how do you figure out how to connect them? And so this is a massive model comparison / Bayesian graph neural networky type problem, which is like computationally intensive. Like that's I'd put that in quotes, but it would be like several sets. That's how much scare it is. That's what we're working on, right? We're working on pushing, seeing how far we can really push this Bayesian brain hypothesis, but not just sort of saying there's a prior, by saying there's lots of them and they interact in interesting ways. And at that point, is it still a prior, Vicente, or has it become something else? Right?
I mean, this is kind of the agreement I reached with Maxwell, for instance, but with other people there, right? Yeah, I mean, and I think it is good. I don't like the idea of prior knowledge or one prior or many of them. I think there are other ways. We like to talk about ecological constraints that are not inside here, out there, but blah 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 blah. But what I try to do is no priors. Let's see how far I can go, and it's fair that you guys do. Okay, this set of priors. Let's see how far, and that's it. I think that's good for science, actually.
Yeah. No, that's the whole point, right? Because eventually, what we want to do is Bayesian model comparison between your approach and mine, because Bayesian is the only way to do it, obviously.
I think you guys are going to meet.
It was an absolute pleasure chatting with you all.
Well, it's been an absolute pleasure to witness it. Thank you guys for coming on the podcast, and I'm sure there are some people out there, devilish people, who expected pots and pans to be thrown across webcams, but this is what science is about at the end of the day, finding convergent paths and trying to get closer to some approximation of truth. So hopefully we've contributed. Sorry, no, and you both leaned back simultaneously when I said that word. Okay, something that helps us predict and data convert. There you go, Jeff. But thank you guys again from me and the Institute, and everyone listening, definitely check out Jeff and Vicente's work. So thank you again.
Thank you.